Hello guys, welcome back to the channel. So today we are going to learn about Dijkstra's algorithm. So some of the people used to call this as Dijkstra's algorithm or Dijkstra's algorithm. Whatever the pronunciation is, it is correct. And now I ensure that I will explain you this particular algorithm in a very simple manner. First of all, this is an iterative algorithm that iteratively finds the shortest path from a fixed source. You have to keep in mind that this particular algorithm uses only a single source vertex. There are other algorithms which use multiple vertices as sources, but this particular algorithm uses the single fixed source vertex in order to find the shortest path from that particular source vertex to all the possible vertices. The rule here we have to follow is we have to cover all the particular vertices which are given in the graph. And this particular Dijkstra's algorithm is not properly working with negative edges. Negative edges in the sense might be backtracking or completely a different concept. But as of now, we use this negative edges in Bellman-Ford or Floyd-Warshall algorithm sometimes. I'm not very sure that we can use or not, but I'll let you know in the upcoming videos. And as of this particular algorithm, we cannot use negative weighted edges. And this is basically a greedy algorithm. So we always rely on the local optimum in the sense, the most feasible solutions, not the best optimal solution, the most feasible solution which is having. Later we go with the same solution as the optimal solution. Okay, so where do we use this discussion algorithm is Google Maps and computer networking. We used to use this. If you observe in the Google Maps, we have this particular algorithm. When we want to go from Vijayawada to Elur, we can go via Hanuman Junction. We can go in any other way, but the way the Google Maps is suggesting you to go in this particular route only because that is the shortest path. You can also come from Vijayawada to directly, you can go for Bhimadolu and Bhimadolu to back to Elur. You can also come like that. Another simple example is Vijayawada to Dwarka Tirumala. You can go via Nalajarla or you can go via Bhimadolu. Both are somehow similar, like almost have the same. But most of the time, what does the Google Map suggest you? Go via Bhimadolu, and from Bhimadolu, about 15 kilometers, you can go to Dwarka Tirumala. That is the basic particular algorithm that is being used by the Google Maps in order to suggest you for the shortest path. Some people blindly might go for Nalajarla also. Even though Google Maps changes itself in order to ensure again shortest path from the Nalajarla. So that is how this particular discovery algorithm works. So everywhere, whenever we are going from one vertex to other vertex, it will ensure that we definitely choose the shortest path. Okay. So next, there are four particular rules in distance algorithm. First one is no negative edges, and we have to go from a single source to all other distances. Particularly, we have to set all those distances as infinity because we don't know what is the distance initially from Vijayawada to Dwarka Tirumala. Okay, so let us say A is Vijayawada and let us say F is Dwarka Tirumala. Okay, so when I am wanting to go from Vijayawada to Dwarka Tirumala, I don't know what is the distance from each and every place. Like I don't know what is the distance from Hanuman Junction. I don't know what is the distance from Elur. I don't know what is the distance from Bhimador. I don't know anything. From where to where, what is the distance? I don't know. So I keep all the vertices as infinite. Then I use this particular formula. That is d of c. What is d? Distance of the particular c plus distance of its adjacent vertices. Means it c in the sense the current vertex. Distance of the current vertex plus the distance of its adjacent vertices. If it is less than the actual distance of the adjacent vertices, we update the adjacent distance with new shortest path. I'll let you know. For suppose we have here a. So this is the vertex where we are starting from. So initially from Vijayawada to Vijayawada distance is 0 only. So we keep it as 0. When you are wanting to go to Gannavaram, which is B, there is a distance of 2. So we will add 2a because from Vijayawada to Gannavaram it is 2. So from A to B it is 2, means 2a. So like that we used to represent. Then again we have C. This is, let us say this is as Hanuman Junction. We can go with that. So 4a. Why it is 4a? Almost half of the distance of Gannavaram to Vijayawada is equals to the single distance of Vijayawada to Hanuman Junction. Might be, might not be exact, but approximately that is the particular distance, about 30 kilometers almost, right? 30 to 35 kilometers, I think so. So that is a situation where we use 4a in order to represent Hanuman Junction. Then, do we know the distance from A to D directly? No, we don't know the distance for Nalajarla. We don't know the distance for Bhimodol. Ah, we don't know the distance for even Dwarka Tirumala also. Keep them as infinity. Next, in from the B vertex, if you observe, now we have updated d of 0, which is current, that is 0, plus its adjacent vertices. We have to select always the minimum one, as you know. So we will go with the minimum one. We have d equals to, then we have this particular b. On this b, we represent d equals to, means the total distance we have traveled is 2 units. Let us say from Vijayawada to Gannavaram only we went. We did not went to directly Hanuman Junction. We first went to Gannavaram. Then, now here if you observe, we have a shortest path. From A to C it is 4, but from A to B to C it is 3 only. So you can choose this particular path. So what do? We just select this path. So we go from Gannavaram to Hanuman Junction. That is B to C. Next, from D, like I mean, we have to find what is the possible nearer cities, right? So from Gannavaram we have Hanuman Junction. From Gannavaram we can go to this particular Bhimadolu. From Gannavaram we can go to Nalajarla also. So we have possible path from Gannavaram. So now we are at Gannavaram. We are also trying to go to Hanuman Junction, Bhimadolu, Nalajarla. What do we select first? Hanuman Junction, because this is the least cost. Na? So when we come to that city, city was completed. Okay, from there we can check whether we can go for the other cities or not. So what do? We used to fill. As we have filled 3b, next we go with 2 plus 4, that is 6b. 6b. Every time here you can observe only A's are present. 2a, 4a. Here only B's are present. A is existing. But from the next very next, when we are changing something, I have to change the particular vertex also. That is what we have to include all the things. And then now from B to E means from A we have to count. Okay, from Vijayawada to Gannavaram to Vemadolu. 4 units of distance is there. Okay, so 4. Next from C. Now we have come to C as this was the least cost path. Now we are at Hanuman Junction. From Hanuman Junction, we can directly go to Bhimudal. There is no other path to Nalajarla or anything. So directly we can come to Bhimudal. In the Bhimudal, directly we can add this, right? So what is that leftover thing? Nothing. We are not modifying any paths we have. So we are keeping all the things as it is because the only path is C to E, and we are not like we are going to it, but we are not updating here because there is no use of updating there. Next, from E we have again we can go to from Bhimdol to Nalajarla and Bhimdol to Dwarka Tirumala. Our destination is to go with Dwarka Tirumala because it is nearer, na 2 units only. But the rule is we have to cover this particular Nalajarla also. So what do na? First we go with this, backtrack this because we have to cover all possible paths. So when the next time we are going from Vijayawada to Dwarka Tirumala, we will ignore this Nalajarla. We will ignore this Nalajarla. If possible, we will also ignore Gannavaram. Directly we can go to Hanuman Junction. There is no issue. We can go, right? But we can't ignore Gannavaram. When we are flying from Vijayawada to Tadepalli or somewhere else, we can ignore. But on the road transport, if you observe, We can't ignore Gannavaram. So that is common. Now from E to D we have 3 units. From E to F we have 2 units. So just update first E. From A to E, what is the distance? 2, 2, 4. So only 4. So 4B. Next, from A to F, what is the distance? 2, 2, 2. 6E. So whenever we are updating, its previous vertex will be taken. Next, now we will go with the D. Why going with D, bro? There is a rule now. We have to traverse through all the possible vertices. So for the next time, whenever we want to optimize the solution in the time of programming, we can ignore the vertices directly. And there we can have our own logic. But as per basic rule, we have to cover all the particular possible vertices. So from D, if you observe, there is no change. So we just copy paste this particular line again here. And finally from F, zero distances from A because there is no direct edge. All the things will be coming as same. There is no difference. So finally from Vijayawada to Dwarka Tirumala, we have reached our destination. ఫైనల్లీ శ్రీవారి దర్శనం అయిపోయిన తర్వాత పెద్ద లడ్డు తీసుకుని ఇంటికి వచ్చేసి హాయిగా తింటాం. ఎంజాయ్ చేస్తాం శ్రీవారి ప్రసాదం. ఓకే. సో దట్ ఈస్ ద బేసిక్ form of completing this problem. What we need to do? Make sure no negative edges. Are there any negative edges? No. Relax all vertices adjacent to the current vertex. Relax in the sense, this is the process. This is what meant by relaxation. So whenever we reach its adjacent vertices, we'll relax them. తగ్గు నేను వస్తాను వచ్చినప్పుడు చూద్దాం అంతే. Choose the closest vertex as the next current vertex. Now here A to B. 2 is greater, 4 is greater, 4 is greater. So leave it. 2 is smaller, na? So take that particular vertex and add it to the next vertex. What we are going to, what we are going to reach. And next, repeat rule 2, rule 3 until the Q or the reach destination. Same thing. Relax all the vertices. Choose the closest vertex. Relax in the sense, just updating the values. After the relaxation, what particular vertex has the least value, we will select that. We will go through that. That's it. So for this, we assume cost is always greater than 0. And for E in the graph. And basically, this particular, we have shortest path from source, that is V, will be determined using, if we maintain a set of vertices, yes. So in that particular vertices only, we can try to ensure that all the vertices are covered from this particular source in order to determine the particular shortest path from that particular source only. And then what do? We select the minimum distance node U, which is not in S, which is not in S. Okay. So for each node W adjacent to U, we do two things. First one, we check a condition. If the distance from the W is greater than distance of U plus cost of U plus W, then only we will update this as a distance of U plus cost of W. Because we have to go with the minimum value. So whatever the distance is greater than, we will equate this particular distance plus the cost of traveling from U to W as a distance of W. So we will get the minimum distance. Then repeat step A and B until S is N. S in the sense the number of set of vertices, and N in the sense the number of vertices. So we have to repeat until this particular process is N. మీకు అర్థమయ్యేలా చెప్పాలంటే ఇది ఎస్ అనుకుంటే ఇది ఎన్. సో ఇక్కడ 5 వర్టిసెస్, ఇక్కడ 6 వర్టిసెస్. యాజ్ లాంగ్ యాజ్ సారీ, ఇది ఇక్కడ 6 వర్టిసెస్, ఇక్కడ 6 వర్టిసెస్. యాజ్ లాంగ్ యాజ్ we traverse through all the vertex, here the number of what is the set of vertices we take, and the number of vertices n, both should be equal. 6 and 6 both are equal, so we stop the traversing. So inputs, V is the source vertex from the shortest path calculated. Cost, the adjacent matrix representing the cost ij, is the weight of the edge from vertex I to vertex j. So if there is no direct edge, it's typically set to infinity. As I have told you initially, we set all edges to infinity. And the distance obviously we will take an array, and n is the particular number of total vertices in the graph. What we will output as a result is we used to have this shortest path distance array. We will mostly output that distance array. Then these are the algorithm steps. I'll share the PPT in the Git repo. You can go through it and you can understand what is happening and everything. So this is discussed of the algorithm. So if you have any doubts, please don't hesitate to comment in the comment section, and I'll try to rectify as soon as possible. Thank you. Bye bye.